All right, Honeydew, looking at this question that you sent me, I think what we want to start with on a problem like this is we want to start by breaking down each of the terms separately and simplifying them as much as we can. Because if we're going to do anything with an addition problem like this with radicals, we've got to find that we have like radicals. And at this point, we just don't know whether we do or not. So what I'm going to do first here is I'm going to look at each of the two terms, I'm going to simplify them down, and I'm going to hope the radical parts become the same, because if they do, then I can add them together by just combining the coefficients. I apologize, I forgot my stylus at home today, so I'm having to do this with my fingers, so if the handwriting is not great, that's why. But hopefully it'll at least get you started. So what I'm going to do first is I'm going to take a look at this 4 times the square root of 5x to the third term. I'm going to simplify it down. Okay, so we want to break it down by looking at each of the factors inside the radical one at a time. And the square root of 5, not much you can do there, right? So we can't really do anything with the square root of 5. Now the x to the third, we want to simplify that down, and we looked at a couple of different ways to break that down. The first one, I would say I could do like an x times an x times an x. That's equivalent to x to the third, right? And because I'm taking a square root, what I'm looking for here to simplify this down is I'm looking for pairs of the same factor inside my radical. So I got a couple of x's, right? Every pair of the same factor inside my radical is going to let me pull one of those to the outside. So I'm going to be able to pull a single x out, right? The 4, I can't lose that. It's a key to these problems is don't lose your coefficients. It's a very easy thing to have happen. But the 5 is going to have to stay inside. And then if you notice over here, I do have this 1x that was not part of my pair, so I've got to leave that inside also. Now that's one way to deal with it, and it's probably the simplest way to see it. It starts to not work so well when your exponents get bigger. If you have an x to the 15th or something that you don't really want to write 15x's out. So we need another way for that kind of situation. So another way to deal with this would be to say, okay, I have 3x's on the inside. My index implied up here is a 2, right? So I can divide my power on the inside by the index on the outside, right? 2 goes into 3 one time. 1 times 2 is 2, with 1 left over, right? That quotient, this number up top here, that tells me how many come out. So I'm able to pull 1x out because my quotient is 1, and I've got 1x left over that's got to stay in. So we get the same answer either way. But basically this is all the simplification we can do on this first term. So we'll have 4x times the square root of 5x. So I'll go ahead and put that in over here for my first term. Okay, and now we'll do the same thing for the second term. Okay, so we got 3x times the square root of 45x. This time, we can definitely do some simplification with our number there. We got 45, and if it's me, I'm doing a prime factorization on this thing, looking for pairs of numbers in my prime factorization. So 45 ends in 5, so I would probably start with a 5 here. Okay, 5 goes into 45 9 times, and then 9 is divisible by 3. 3 is divisible by 1. Okay, and then we're done, right? So looking again, we're doing a square root, so we're looking for pairs of numbers in our prime factorization. So I've got a pair of 3's here, okay? So I'll be able to pull a single 3 out. Every pair of numbers in your prime factorization is going to let you pull one of those numbers to the outside. So I've got my 3x. I want to bring that down. Don't want to lose it. I'm going to pull another 3 out because I had a pair of 3's over there. And then inside, I've got to leave the parts that weren't able to pair. In this case, I have that 5 that didn't pair. Got to leave it inside. And then I've got that x, a single x inside of a square root like this. There's nothing we can do to simplify that. So I'm going to go ahead and bring that down. And then I've got those 2 3's on the outside. They're multiplied together. I can go ahead and multiply them like so. And there's my simplified form for this term. So 9x square root of 5x. Okay? So I'll go ahead and put that in over here. And now, if you look at the radical and variable parts on these things, they're identical at this point, right? We got x squared of 5x at the end of each of our terms. That makes these terms like, and that means we can combine them by adding the coefficients. So 4 plus 9 is 13. Don't change the radical or the variable part at all, just like when we were combining like terms just for polynomials. Same kind of setup there. And so 13x squared of 5x is what we're looking for. So hopefully this is helpful. If there's anything that's not clear, please let me know, and don't hesitate to ask me more questions.